Okay, welcome back to part 2 of section 1. Today we're going to talk a little bit more about the actual formulas that we use to talk about arithmetic and geometric sequences. So, I've given you a couple sequences here to start off. The first sequence I've given you is A and A plus D and A plus 2D and A plus 3D. And then I've given you a little bit more sequence, 2, 5, 8, and 11. Now, each sequence has a specific number of terms. This term could be the nth term, the first term, the second term, the third term, the fourth term, all the way up to the nth term, depending on how long it is. We call these terms, if it's the first term, T1. So here, that would be, n is 1, the first term. The second term would be term 2, or T2, where n is 2. The third term would be T3. The fourth term, T4. All the way up to Tn, depending on how long it goes. So you could put comma, dot, 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 all the way to Tn. There are 10 terms. They'd go to T10. So for instance here, 2 is T1, and 5 is T2, and 8 is T3, and 11 is T4, where n can take on the values 1, 2, 3, and 4. And it goes all the way to Tn. Now, there's actually a formula here. Check this out. To get 5, you could do 2 plus 3 times 1. I want you to just write that down for right now. To get 8, you could do 2 plus 3 times 2. To get 11, you could do 2 plus 3 times 3. There's a formula for each of these terms. T2, where n equals 2. T3, where n equals 3. T4, where n equals 4. That's the second position, the third position, the fourth position. This n is directly related to what you are putting in the parentheses each time. See, here it was 4 and we put a 3 in. Here it was 3 and we put a 2 in. Here it was 2 and we put a 1 in. The formula for Tn in this case would be take 2, that's your starting term, and add 3 times. If you're looking for the nth term, you need to put n minus 1 in the parentheses. Just like here, we were looking for the fourth term. We had to put n minus 1, which is 3, in the parentheses. That's the formula that governs that particular sequence. Similarly, over here, the formula for the nth term would be equal to the first term plus the term you're looking for, minus 1, times, over here we multiplied it by 3. That's because the common difference each time was what? 3. So you multiply by the common difference each time. And that, friends, is your formula for an arithmetic sequence. Tn equals T1 plus n minus 1 times d, where Tn is the nth term, T1 is the first term, n is the position, like the second position, third position, 100th position, and d is the common difference. Now, this should look somewhat familiar to you. Arithmetic sequences and the formula for them is nothing more than a common line, because it's got a slope, it's a constant rate of change, it's a constant common difference. That's all an arithmetic sequence represents, is some linear function. Now, geometric sequences, slightly different, but similar nonetheless. Let's say you have your first term is T1. Let's call it A. So, here, this is where n equals 1. Let's say your second term is AR, where n equals 2 because I'm in the second position. Let's say your third term is AR squared, where n is 3 because you're in the third position. AR cubed, where n is 4 because you're in the fourth position. Do you see a formula here? That should be AR cubed. The geometric sequence formula for the nth term is always equal to your first term, which in this case was A, I'll put T1, times R, but R is always raised to some power. For the fourth term, it was raised to the third power. For the third term, it was raised to the second power. So it's raised not to the n power, but to the n minus 1 power. That's your formula for a geometric sequence. Let's review what all these terms are. Tn is the nth term. T1 is the first term. R is the ratio. And again, n is the position that you are interested in. Now, this is not a linear function. This is the definition of an exponential function. And you've seen this before. Y equals a times b to the x. A is just like your T1. B is just like your ratio. And x is your exponent, which is n minus 1 in this case. So what about the case when you have an undifferentiated sequence? In other words, you're talking about a sequence that's neither arithmetic nor geometric. Well, these can be a little interesting at times. I think they're fun. So I've given you an example of an undifferentiated sequence, 2, 5, 10, 17, where 2 is the first term, 5 is the second term, 10 is the third term, and 17 is the fourth term. So in green, I've got the n's. Those are the position. In white, I've got the tn's, the actual terms themselves. There's a formula that will govern this particular sequence. Let's see if you can figure it out. This is crazy. Are you ready for this? How do you get from 1 to 2? 1 to 2. How do you get from 2 to 5, 3 to 10, and 4 to 17? Do you see a pattern there? Well, take each n. This should have been an equal sign right here. And square them. 1 squared is 1. And 1 plus 1 is 2. 2 squared is 4, and 4 plus 1? That's 5. 3 squared, 9, and 9 plus 1 is 10. 4 squared, you got it, is 16. And 16 plus 1 is 17. This is your formula for this undifferentiated sequence. These are tricky because no two formulas are exactly alike. Whereas if it's arithmetic or geometric, you have formulas that always fit the recipe. But those are kind of boring. I like these because they're always a little different. So use this formula. What's the 11th term? So find t sub 11. Find the 11th term. Well, you take the 11th, you take n equal 11, so you have 11 squared plus 1. 11 squared is 121 plus 1 is 122. That would be the 11th term in this sequence if you kept going out. We've only got the first 4 terms written. Pretty cool stuff. What you're looking for in the undifferentiated sequences are patterns. Any kind of pattern you can find. And sometimes, if you're lucky, there's more than one answer. And you might find more than one formula that works. Okay, so here are your directions. Is this sequence arithmetic, geometric, or neither? And then I want you to find a formula for Tn, and not only that, I want you to actually go ahead and find T sub 8, the 8th term. Well, let's look for a pattern. Pattern's pretty easy to find on this one. 15 minus 4 is 11, and 11 minus 4 is 7. So this is certainly an arithmetic sequence because it has a common difference. That common difference, -4. So we have a formula for arithmetic sequences. It's Tn equals the first term plus n minus 1 times d. And to write the formula, you need three things. You need T1. I'm sorry, you just need two things. You need T1 and you need D. T1 and D. Well, T1 is the first term, which in this case is 15. Let me put a little T1 above him. 15 plus n minus 1 times the difference, which is -4. Now, technically, I was supposed to say n minus 1 in there. Let me clean that up just a bit. It's pretty sloppy. Technically, this is done, but I'd like for you to go ahead and clean it up a little bit by distributing the 4. So it's -4n plus 4. Answer for Tn, your formula, is 19 minus 4n. That formula will give you whatever term you'd like to find. Let's suppose you want the 8th term. Well, it'd be 19 minus 4 times 8. And 19 minus 32 is -13. That would be the 8th term. Now, I suppose you could have figured that out by just simply subtracting 4, subtracting 4, subtracting 4, subtracting 4. But what if I'd asked you to find T800? Well, you'd be here for a long time. Why not just make your life easier and use the formula that you just generated? Up here, I probably should have put T1 as 15 because those are the two pieces of information I needed to find a formula for Tn. Okay. So, here's your next sequence. I want you to determine if it's arithmetic, geometric, or neither. And hopefully this part's getting a little bit easier by now. This is not arithmetic, but if you take the second term and you divide it by the first term, you get the cube root of 2. And that'll happen over and over and over. So this is actually geometric, with a common ratio of the cube root of 2. Formula for a geometric sequence, was the first term times the ratio to the n minus 1 power. Well, T1 for us is the cube root of 5, and the ratio for us is the cube root of 2. Let's fill that in. T1 equals the cube root of 5 times the cube root of 2 to the n minus 1 power. Sweet! That's your formula for Tn. I suppose you could write that a little bit differently if you'd like to split it up using the split approach with that exponent, but I'd be okay with this. Alright, let's find T sub 8. So to find T sub 8, the 8th term, put the cube root of 5, the first term, times your ratio, the cube root of 2, and raise it to the 8 minus 1 power, or to the n minus 1 power. Well, that really just says the cube root of 5 times the cube root of 2 to the 7th power. Well, that 7 can also be written on the inside. So it's the cube root of 5 times the cube root of 128. 128 is really just 2 to the 7th power. Well, the cube root of 128 can be broken down. It's really 2, 2, 2, 2, 2, 2, and 2. And since you're looking for triplets, you get to play circle, slash, slash. Circle, slash, slash, and he's a bum. He stays on the inside. So, 2 2's get out, which is really a 4. And there's still a cube root of a 2 left on the inside. Not only that, there was still a cube root of a 5 out here. And all this can be multiplied together if it's on the inside of a radical. So multiply these two together. Final answer for T8, and this was a tricky one, 4 is on the outside, times the cube root of 10. Check that out. Isn't that saucy? I love it. Good stuff. Okay, your next one. Here we go. 1 times 2 and 2 times 3 and 3 times 4 and 4 times 5. That really just says 2, 6, 12, and 20. Well, if you remember right, we did this sequence in the first video, and it was a neither. So I want you to write neither right here. That is, there's no common difference and there's no common ratio. This is an undifferentiated sequence. So you all are going to have to try and find a pattern for this sequence. Now it helps to write out your n's. Here, n is 1. Here, n is 2. N is 3. N is 4. Oh, I messed that up. Let me fix that before I confuse you anymore. N is 1 is really 1 times 2. 2 times 3 is n equal 2. 3 times 4 is n equal 2. 4 times 5 is n equal 4, and so on. This is T1. This is T2, term 2, term 3, and term 4. Do you see a pattern? Well, notice here, in each term, you see n, don't you? 3 and 3, 4 and 4. So our formula for Tn is to simply take n itself and then multiply it by the next highest number, or n plus 1. N plus 1. 1 times 2, 2 times 3, 3 times 4, 4 times 5. N times n plus 1. That's your formula. Or, I suppose, you could write it as n squared plus n. Let's see what T8 is. Well, T8 says to take the 8th n times the 8th n plus 1. So it's 72. Or, if you'd like to leave it, you could rewrite it as 8 times 9. Those are my favorite types of problems, the undifferentiated ones. Love those. Okay, in example 3, you're going to find a formula for Tn, given that T2, the second term is 2, and the fifth term is 16. And I'm also going to tell you that this is an arithmetic sequence that we're working with. So since it's arithmetic, you should know the formula that your final that you'll use the nth term is equal to the first term plus n minus 1 times the common difference, d. Now, to write a formula in this form, you need two things. You need T1 and you need D. Those are the two things that you need, and we don't have either. Let's see if we can figure them out. Well, I do know what T2 is, so I'm going to write that. T2 is 2. I don't know T3. I sadly don't know T4, and I do know T5. It's 16. I'm going to put blanks here in those places. Oh, also, I don't know T1. And that's sad because I need to know T1. But what I do know is that if I go from T2 to T3, since it's an arithmetic sequence, I'm adding some common difference each time. See that? Well, that tells me that I also know this, that to get from T2 to T5, I start with T2, I add not 1, not 2, but 3 D's, and I get 16. Well, that just helped me a lot, because now I can figure out what D is. D ends up being 14 thirds, or 4 2/3. So D is 14 thirds. Well, now I can figure out what T1 is by working backwards. Instead of adding D, you'd actually subtract D. So you'd subtract 14 thirds. And 2 minus 14 thirds, or 2 minus 4 2/3, is negative 2 2/3, or negative 8 thirds. So now I know T1 is negative 8/3. And because I now have the first term and the common difference, I can write my formula. And here it is. It's the first term, negative 8/3, plus n minus 1 times the difference. The difference being 14/3. And technically this is done, but I'd prefer that you go ahead and distribute the 14/3 and kind of clean it up a little bit. And you'll end up with the following. You'll end up with negative 22/3 plus 14/3 n. Technically, either one of those will work. I prefer the second one. Now what if I give you the same information, but instead of the sequence being arithmetic, it's now geometric? So the sequence needs to take on this formula now. First term times r to the n minus 1 power. Again, you need two things. You need T1 and you need r. And we don't have either. However, again, we know that the first term is 2. I'm sorry, the second term is 2. So I'll put a little T2 above there. And the T2 we don't know. T4 we don't know. Does this look familiar? T5 we do know. 16. Blank, blank. T1, blank. But instead of adding D to get from one term to the next, you're multiplying by r. So to get from the second term all the way to the fifth term, you're actually taking the second term and multiplying it by r, and r. Well, a simple way to write that is r to the third power. That's equal to 16. Well, now you can solve pretty easily for r. R cubed is 8. That means r has to be 2. Sweet! I'm going to write that up here. R is 2. Now, I can work backwards. But instead of multiplying by r, you would actually be dividing by r to get back to here. So divide by r. Or you could times by 1 over r if you'd like. So take 2 divided by 2, or 2 times 1/2. And the first term had to have been 1. First term had to have been 1. Sweet. So here's my geometric formula. T sub n equals my first term 1 times r, which is 2, to the n minus 1 power. Well, that can be simplified. Be written as 2 to the n minus 1 power. And then, if you're feeling saucy, let's split that up. Let's make that really say 2 to the n times 2 to the negative 1. Right? You can do the split approach here. Well, 2 to the negative 1 is really just 1/2. So this really just says 1/2 times 2 to the n power. And that looks a lot cleaner. I like that formula a lot. Technically, this is right. I'd prefer that you clean it up using the split approach. It's pretty easy to do, so I don't feel bad asking you to do it. Alright guys, that's all I got for you in section 1. Hope you had a good time. I know I did. Catch you later. I'm out.